Imagine a gigantic troupe played by an unending number of stars, planets, and moons, all performing together superbly. In any case, there is one explicit fragment of this orchestra that has bewildered space specialists for a seriously lengthy time span: exoplanets. Exoplanets are standard planets that exist outside our planetary framework, hidden away somewhere deep in the Milky Way. You might be surprised to find that among the gigantic number of galactic objects, there are exoplanets so like Earth, so tantalizingly similar yet bewildering, that they might be our planet's heavenly twin. We dive into the captivating area of Proxima B, found approximately 4.2 light-years away. The James Webb Space Telescope is revolutionizing our mission for understanding these divine secrets. Imagine a moment when your mind ventures across the colossal vastness of our reality, the Milky Way, which is home to more than a quadrillion exoplanets. That is a number with 15 zeros. To put this into perspective, if each of these exoplanets were the size of a grain of sand, we wouldn't simply fill the Grand Canyon. We would have enough to create another landmark on Earth, a Grand Canyon 2.0, that would stretch for a significant distance. What is most astounding is that around 20% of these great bodies have been designated Earth-like in terms of geology and atmospheric structure. That means there is a 1 in 5 chance of finding a twin of our planet. And the story doesn't end there. Alongside these planets, there could be another quadrillion moons, rocky satellites like our moon, trapped in gravitational dances with their parent planets. If you were to contemplate finding another body in space that harbors life or could do so, the universe offers a flood of opportunities. Now that we have spread out the material on an incredible scale, it is time to introduce the master instrument prepared to paint its complex nuances: the James Webb Space Telescope. This heavenly Sherlock Holmes, with its amplified central lens replaced by flexible focal points, surpasses even the most advanced optical instruments. We're not just talking about any lens. Its 6.5-meter primary mirror is 2.7 times greater than Hubble's. Imagine the detail it can capture, even in the faintest glimmer of a star billions of light-years away. What makes the James Webb Telescope revolutionary isn't just its viewing power but also its advanced technology, including sophisticated sensors and spectrographs. These instruments can do more than simply observe. They can analyze and filter the unique light signatures emitted or reflected by celestial objects to decode their atmospheric conditions, density, and even mass. Acting as a space scientist, the telescope can determine if a planet has water, organic compounds, or even oxygen. The James Webb Space Telescope has the ability to answer these questions, elevating it from a mere observer to a scientific genius. It's not just a step beyond its predecessor, Hubble. It's more like a quantum leap. If Hubble's discoveries amazed you, prepare for a genuine spectacle of celestial revelations. As we expand our gaze across the intricate landscape of the universe, it's worth focusing on one specific star in the cosmic symphony: Proxima B. Since its discovery in 2016, this astounding planet has stood out as a Shakespearean character filled with complexity and intrigue, fascinating astronomers and anthropologists alike. Why all the fuss? First of all, Proxima B is practically in our galactic neighborhood, just 4.2 light-years from Earth. To put that into perspective, if you could defy the universal speed limit and travel at the speed of light, you would arrive in just over 4 years, about the same amount of time it takes for your favorite TV show to fall into reruns. But let's delve deeper into why this proximity is so significant. We're talking about a universe that extends more than 93 billion light-years from one end to the other. Finding a planet so close and so promising for scientific investigation is like finding a gem in a mountain-sized pile. This gem could potentially hold secrets about life itself. In the grand tapestry of the universe, Proxima B is a multi-layered thread offering profound clues that could redefine how we understand habitability and life beyond Earth. It's not just Proxima B's closeness to Earth that excites researchers, but also the alluring signs that this planet isn't just Earth-like but potentially Earth 2.0. Proxima B sits comfortably in what astronomers call the habitable zone of its parent star, where conditions are neither too hot nor too cold, just right for liquid water to exist. Imagine waterfalls, meandering streams, massive lakes, and perhaps oceans as deep and mysterious as the Mariana Trench. But before we start dreaming about visiting Proxima B, let's consider a few of its peculiarities. For one, a single day on this fascinating exoplanet lasts an astonishing 11 Earth days. Imagine sunrises that not only usher in a new day but unfold slowly, resisting the shift to noon, and sunsets that linger, creating golden hours photographers dream of. While this sounds idyllic, it also has significant implications for its climate and habitability. How would human biorhythms adapt to the patterns of light and dark on Proxima B? Would we need to eat 3 or 4 times as much in a single day? Would we sleep the same way on this entirely different world? The fundamental patterns of life, as we know them, would be both tantalizingly similar and frustratingly strange. It is as though nature is presenting us with an enigma wrapped in a riddle, challenging our understanding of what makes a planet habitable. You might wonder how we can gather precise and reliable data about a world we've never visited. The James Webb Space Telescope deploys all its capabilities like a giant Swiss Army knife. It's more than just a telescope. It's a complex research lab in the vacuum of space. Thanks to its innovative technology, astronomers not only observe planets but also examine them through a prism of scientific instruments that would make CSI labs look simple. Using advanced spectrographs, the Webb telescope can analyze the light emitted and reflected by these distant planets. Every element or compound in a planet's atmosphere absorbs or emits light at a specific frequency. By studying these patterns, scientists can perform a remote biopsy of celestial bodies, determining not just atmospheric pressure and density but also the possible presence of compounds essential for life, such as water, organic carbon molecules, and even oxygen. This is not just cosmology, it's space forensics. We don't sit idly waiting for signs to come to us. We actively search for them, investigating the atoms and molecules that make up these complex universes. The Webb telescope isn't just an eye in the sky. It's a highly specialized research lab, analyst, and cosmic detective all in one. It allows us to turn our theories and hypotheses about alien worlds into frameworks to confirm or refute them, revolutionizing our understanding of what could exist beyond our pale blue dot. Just when you thought you had uncovered the most dazzling layers of this cosmic onion, the story takes an unexpected turn. Much like a plot twist in a science fiction thriller, scientists using the James Webb Space Telescope detected something extraordinary from Proxima B, a signal so astonishing that it sent ripples through academic circles and social media. Dubbed a potential technosignature, it was an electromagnetic emission so complex and intricately patterned that it could hint at the presence of an advanced civilization. The collective heartbeat of humanity seemed to pause at the prospect of a discovery that promised to reshape our understanding of reality. Could the signal be the definitive proof that we are not alone in the universe? And just as quickly as it appeared, the signal vanished without repetition, leaving behind not only a profound silence but also a labyrinth of unanswered questions and swirling speculations. Was it merely a transient cosmic anomaly, a coincidence of celestial alignment, or something more deliberate, a coded message or even a sign of extraterrestrial intelligence? This solitary signal cast a shadow of mystery over Proxima B, igniting fierce debates and theories. Was it just a passing oddity? Or is it part of a much larger story, more intricate than we can imagine? But wait, the narrative of our cosmic exploration is far from complete. The ink has not yet dried, and new chapters are still being written. This time, it's not just conventional scientists but Harvard researchers leading a paradigm shift in the search for extraterrestrial life. They are not content with merely investigating the signals and phenomena we've discussed so far. They are raising the stakes by turning the James Webb Space Telescope into a kind of giant night vision telescope. Their goal? To search for artificial light sources in both the dark and illuminated regions of distant worlds. We're talking about staggering possibilities, such as detecting artificial adaptations of cities glowing in the dark like luminous beacons. Imagine seeing the shining lights of what could be a city bustling with the presence of an advanced civilization, radiating its brilliance into the vast cosmic seas. As we continue to unravel the mysteries of the universe, the quest for extraterrestrial life takes on new dimensions. Beyond the immediate intrigue of Proxima B, our grand search delves deeper into the immense new territories of space. This pursuit is driven by both technological advancements and a profound sense of curiosity about our place in the universe. Ongoing breakthroughs in astronomy and space exploration have led to the discovery of numerous exoplanets with potential habitability. Instruments like the James Webb Space Telescope, biosignature detectors, and ground-based observatories have expanded our ability to identify and study these distant worlds. One particularly fascinating area of study is the search for biosignatures, signs of life. These indicators could include atmospheric gases like methane or carbon dioxide, which, under the right conditions, might suggest biological processes. The James Webb Space Telescope's capabilities extend beyond simple detection. Its advanced instruments can measure the atmospheric composition of exoplanets with remarkable precision. By studying starlight that filters through an exoplanet's atmosphere, scientists can identify chemical markers indicative of life. For example, the presence of water vapor alongside other key molecules, such as oxygen or ozone, could point to the potential for life-supporting conditions. Another avenue of exploration involves examining the conditions of these distant worlds. Climate models based on data from the Webb telescope can help predict whether an exoplanet's environment could sustain liquid water. This is crucial because water is considered a fundamental ingredient for life as we know it. Scientists are particularly interested in planets located in the habitable zone of their parent stars, where temperatures might allow stable liquid water. The search also extends to the moons of exoplanets. Some of these moons, especially those in the habitable zones of their host planets, could harbor conditions conducive to life. For example, icy moons in our own solar system, such as Europa and Enceladus, are thought to contain subsurface oceans beneath their frozen crusts. Similarly, moons orbiting exoplanets could present comparable conditions where life might exist. In addition, the concept of technosignatures has gained traction. These are indicators of advanced civilizations that might be detectable through artificial structures or technologies. This could include megastructures like Dyson spheres, hypothetical constructs designed to capture a star's energy, or unusual patterns in radio transmissions.